Good afternoon, this is Miss Parks, and now we're going to be talking about the sum and difference identities for cosine. So there are two of them here. Okay, and we are going to be using these to find these values. So normally on the unit circle, we don't have the cosine of 15 degrees. So we have all the, we have 30 and 45 and 60 in the first quadrant. And then we have in the second quadrant 120, 135, and 150, so on and so forth. So when you're using unit circle, you can follow along with this. But basically, we're going to be using these functions. We're not allowed to distribute. So what we're going to do is we're going to take some of these numbers to be able to come up with that number. Okay, down here, cosine of 15. So there are many different ways that you can get to 15. You could do 45 minus 30. You can do 60 minus 45. You can be 135 minus 120, 150 minus 135, so on and so forth. You can do all of these. I'm obviously going to pick the one that I think is easiest, so I'm going to be using 45 minus 30. Now, in order to do that, this is an a minus b. So we're going to be using this function, cosine of a, cosine of b. Okay, this is a and this is b. And then there's a plus, even though this is a minus, plus sine of a and sine of b. And now we just fill these in with the values that they have at those points on the unit circle. So radical 2 over 2, cosine of 30 is radical 3 over 2, cosine of 45, radical 2 over 2, and sine of 30 is 1/2. Here, we multiply these. You multiply the top, and you multiply the bottom. Same thing here. Multiply the top, multiply the bottom, and that's it. That is your answer. So the answer to cosine of 15 is radical 6 over 2, or excuse me, radical 6 over 4 plus radical 2 over 4. And you'll see that those answers come up over and over and over again for sine and cosine. Okay? All right, let's go ahead and do the next one. So for 5 pi over 12, we're going to change this into degrees just because it's easier to work with for most of us. Okay? So if you multiply this out, you're going to get cosine of 75. So for cosine of 75, there's many different ways to do this also, but I'm going to choose what I think is the easiest one. So like I don't want to do 210 minus 135, although you could, that's 75, but it's just easier to do cosine of, let's just do 45 plus 30. We just did 45 minus 30, so this one should be similar. Cosine of 45, cosine of 30, and then in this case, if that's plus, that's minus, sine of 45, sine of 30. All right, so same thing. We already know these values because we just did them. And then sine of 45 and sine of 30. I know I'm going through that fairly quickly. You're going to have a chance to actually do them down here. But hopefully it's no surprise to you, or maybe it is, since we're just started this, that it's radical 6 over 4 minus radical 2 over 4. Okay? Now, for the next problem, they give you the formula and you're going to work backwards, right? So they give you this formula with a minus sign in it. So this is A, and this is B. Because that's minus, then we're going to have 87 plus 93. So we're undoing the formula. So that's going to give us cosine of 180 degrees, and cosine of 180 is equal to -1. Okay, so now it's your turn to try these problems. They're very similar. You already have the formulas in front of you. Please go ahead and try them. Pause the video And then come play it once you're done doing all three of those. Maybe before you start, what I don't want you to do is I don't want you to do negative 45 minus 30. You could. However, if you did this, then A would equal negative 45, B would equal 30, and then you would have to use the minus or the subtraction formula. So I wouldn't do it that way. So use some numbers where you have a smaller number minus a bigger number to get that negative 75. All right. And if you're not sure, I'm going to use 60 minus 135. Okay, and these are all in degrees. It's okay if you don't use the degrees all the way through the problem, but just know these are all in degrees. All right, again, hope that you finished all of these first. Here we go. Cosine of 60, cosine of 135, plus sine of 60, sine of 135. Next, cosine of 60 is 1/2. Cosine of 135 is negative radical 2 over 2. Be careful that you need to make sure you use the correct signs. Plus radical 3 over 2 times positive radical 2 over 2. So this will give us negative radical 2 over 4 plus radical 6 over 4. Regardless of which numbers you use, you would get the same answer. It might not be written in this order. You might have radical 6 over 4 minus radical 2 over 4, but the radical 6 over 4 will be positive, and the radical 2 over 4 will be negative. All right, and you might see it written as like radical 6 minus radical 2, the whole thing over 4 as one fraction. That's okay also. I'm going to leave it as 2. All right, for the next one, I'm going to multiply this by 180 over pi. That's going to give me cosine of 255. Again, you might want to have a unit circle handy and then just try some numbers and see which ones add up to that. So I'll be using 210 plus 45. So cosine of 210, cosine of 45, minus sine of 210, sine of 45. Those are multiplied together. This is negative radical 3 over 2 times radical 2 over 2 minus negative 1/2 times radical 2 over 2. And if I keep going this direction, this right here gives me negative radical 6 over 4. And this part gives me plus radical 2 over 4 because I have a minus and another minus. All right. Last question. Let's see how you did on this. This is a minus. That's A. That's B. So that's going to give us cosine of 173 minus 83, which is cosine of 90, and cosine of 90 is 0. Not 0 degrees, just 0. All right. For the next part, we're going to talk about cofunction identities. Cofunctions are different than reciprocals, and sometimes people get them mixed up, so you got to be very careful. Cofunctions, sine and cosine, okay? So if I have cosine of 90 minus theta, it equals sine theta, and sine of 90 minus theta equals cosine theta. So what does that mean? So if I give you cosine of 90 minus 60, then that equals sine of 60, which means cosine of 30 equals sine of 60. So that means that the sum is 90, okay? Their angles have a sum that's 90. Because if this is theta, and that's whatever number you want to fill in there, if that's 10, then cosine would be 90 minus 10. Okay, if sine was 50, then cosine would be 90 minus 50, so it would be 40. So their angles always add up to 90 degrees. or pi over 2 radians, okay? The other ones, tangent and cotangent, okay? Sine and cosine are cofunctions, tangent and cotangent, and then secant and cosecant. So be careful, don't get these confused with reciprocals, okay? All right, so here we're just looking for theta. So since these are cofunctions, their angles have to add up to 90. So this angle plus that angle have to equal 90. So theta is equal to 65 degrees. Sine and cosine are cofunctions, so their two angles must add up to 90. So theta is equal to 120 degrees. And here, this is in radians, so we're going to leave it in radians. So these are cofunctions, so that means 3 pi over 4 plus theta is equal to pi over 2, because pi over 2 is the same thing as 90 degrees. So I'm going to subtract 3 pi over 4. So that would make that 2 pi over 4 minus 3 pi over 4. So theta is equal to 1 pi over 4. And I don't have a lot of room here. Let me see if I can just extend this down a little bit. So these will cancel, and theta is equal to pi over 4. And again, it's because if you take 2 pi over 4 minus 3 pi over 4, you get pi over 4. So if your question's in radians, please give your answer in radians as well. And actually, that's negative, not positive. All right, pause the video, do the next 3 problems, please. All right, so for the first one, we have, actually this one, the question is a little bit different in the way that it's written. I should have let you do the other 3 up there. But they want to know what the cofunction of the given value is. So they want this entire answer. So they want what's the cofunction of cosecant, and then what's the angle as well. So 62 plus what is equal to 90. So that would be 28. So this is 28 degrees. So your answer is all of this, where in the previous one, the answer was just the theta. Here, the answer is secant of 28 is the cofunction of cosecant of 62. Okay? So for number 2, same question. Number 3, same question, but your answer is in radians instead of degrees. Go ahead and try 2 and 3, please. All right, so the cofunction of cotangent is tangent. They happen to be reciprocals and cofunctions. And then these two angles, so negative 54 plus theta, have to equal 90 degrees. So that means theta is equal to 144 degrees. Again, the final answer is all of this. On the test and quizzes, people tend to write tangent equals 144 or just 144 and not writing the tangent in front of it. So just be careful. All right, for sine of 7 pi over 6, the cofunction of sine is cosine. And then these two angles, we'll call this one theta, have to add up to 90 degrees or pi over 2 in radians. So theta, I'm going to subtract 7 pi over 6. I'll write this small. I'm going to subtract 7 pi over 6. So theta will equal, I'm going to make these both into 6. So we'll multiply this by 3 over 3. 3 pi over 6 minus 7 pi over 6 is negative 4 pi over 6. So that's negative 2 pi over 3. So that's theta. But my final answer is here, negative 2 pi over 3. And that's your final answer, is all of that. Okay? All right. Next. For example 3, we're just going to do the trig identity for cosine of a minus b, write it out, and then simplify. So this will be cosine of 180 cosine theta plus sine of 180 sine theta. Go ahead and write that out and see what you get. Put the values underneath each one from your unit circle, work it out, and see what you get for your answer. All right. Cosine of 180 is -1. So -1 times cosine theta, sine of 180 is 0. So this gives me negative cosine theta plus 0, which is negative cosine theta. And that's it. Go ahead and try example 3, the next example 3. Okay, pause the video, come back and play it, see what you got. Here we go. Cosine of 90, cosine of theta. Be careful not to confuse your theta with your zeros. Minus sine of 90 sine of theta. Cosine of 90 is 0 times cosine theta minus sine of 90 is 1. So we get 0 minus sine theta. So that equals negative sine theta. And that's your final answer for that. All right. So for example 4, there's a little bit of work that needs to be done. The first thing is they want us to find this. So before I do any of the work, I'm going to write down cosine of s plus t, and then I want you to find or write the formula. And please make it, I never round my t unless I'm in a math class, so it doesn't look like a plus. So just be extra careful for your s doesn't look like a 5. Mine does a lot. And that your t doesn't look like a plus sign. Okay? So then I want you to write the formula. And then when you write cosine of s, it's even worse because they're right next to each other, right? Cosine s, cosine t, and then this will be minus sine s, and then sine t. All right? So there are 4 terms that we need to figure out. Now, and there are 2 questions here. But the first thing is that they tell us that sine of s is 3/5. Okay? So I already know that part right there. I also know that cosine of t is negative 12/13. And now I'm going to find the rest of them. First thing, or the next thing, they tell us that both are in quadrant 2. Okay? And if they're both in quadrant 2, actually I'm going to leave that alone. That means that angle S, I want you to label one of them S, and sine is 3/5. So if I do the Pythagorean theorem here, that becomes -4, right? So 9 plus x squared equals 25, x squared equals 16, x equals 4, but it's negative because it's going to the left. Okay? That means that for S, cosine is -4/5. And sine of S and cosine of S will always have the same denominator. Same thing goes for cosine of t and sine of t. They will also have the same denominator. Why? Because sine and cosine both have a denominator of either the hypotenuse or the radius, however you want to look at it. So, for cosine of t, it's also in quadrant 2. And I'm not drawing this to scale, but this is t. Actually, just so you know, the real angle is here, but I'm just putting an S and T in these triangles to indicate which one's which. So this is negative 12/13. By now, you should know where all the numbers go. If you do Pythagorean theorem here, 12 squared plus y squared equals r squared. So y squared equals 25, y equals 5, and it's positive because it's pointing up. So sine is positive 5/13. And now you have all the numbers that you need. All right, so 48 over 65. Do not reduce this, even if you can. The reason why is because both these denominators are the same, and we want to keep it that way. So even though I can reduce 15 over 65, and your calculator might do that for you if you try to use your calculator right away, because you can cancel those 5s. I don't want you to do that, because if you cancel out the 5s, then these are no longer 65 each. And you want them to be 65 each. So that gives me 33 over 65, which is the question that we were answering from the beginning, S plus T. All right, so your turn. Please try the next question. All right, so after you've finished, unpause the video. Here we go. First thing we're going to do is write this down. Cosine of S minus T. Then write the formula down with no numbers. Cosine of S, cosine of T, plus sine of S, sine of T. I'm color coding these as I say that and not use color. Cosine of S is 15 over 17. So I know that sine of S is going to be something over 17. Sine of T is negative 24 over 25. That means cosine of T will also be something over 25. And then we have a plus sign in the middle. Okay? Sometimes they tell you they're in different quadrants, by the way. These are both in quadrant 4. So S, quadrant 4, 15 over 17. If you do Pythagorean theorem here, 225 plus y squared equals 289. Y squared equals 64. Y is equal to 8. Y is pointing downwards, so that will be negative 8. So for S, sine is negative 8/17. And then for T, it's also in quadrant 4. And it's negative 24 over 25. So x squared plus 576 equals 625. X squared equals all right, so x squared is equal to 49. So x is equal to 7, and it's positive 7. Okay. So that goes here. And we multiply this out. All right. All right, so we multiply this out, and we're going to get 105 over 425. And again, I'm not reducing that. Plus, these two are both negative, so they multiply to a positive 192 over 425. And that gives us 297 over 425. Here you would reduce if you could, by the way. It doesn't. And that's cosine of S minus T, which is what they asked us to find in the first place. And that's your final answer. All right. Last two problems, we're going to do some identity verifying again. I know that it's your favorite. So we're going to go ahead and do the work here. All we've learned in this section is the sum and difference of cosine. And so you're going to have to use that. Obviously, you don't see any cosine here, but we see secant. And secant is a reciprocal of cosine. So cosine of 3 pi over 2 minus x. So this is 1 over that. So I'm only going to work with this side for right now. I'm going to use arrows instead of using equal signs so that you know that I'm still working with that side. So that's a 1 at the bottom. That's going to be cosine of 3 pi over 2 cosine of x plus sine of 3 pi over 2 sine of x. And I'm just going to go ahead and work with this down here. Cosine of 3 pi over 2 is 0 times cosine of x plus sine of 3 pi over 2 times sine of x gives me 0 minus sine of x. So that gives me negative sine x, which this is what we're trying to get to. And that's what this is equal to. It equals negative cosecant of x. And now those are identical. Okay? So that's verified. You guys try the next problem. It's the last problem. Don't worry. We'll do a ton of practice on this stuff. Okay? All right. So hopefully you're finished with that by now. This is equal to 1 over cosine of pi plus x. So that's going to give me cosine pi, cosine x minus sine of pi, sine of x, using the sum identity. Cosine of pi is equal to 0. This is equal to 1. All right, cosine of pi, that's at 180, is equal to negative 1. Sine at 180 is 0. So this is equal to negative cosine x minus 0. So if I go this way, this is equal to negative cosine x from here. And that's equal to negative secant x, which is what we need it to equal on this side. They're equal to each other. That's finished. We're done with section 5.3. We'll do some practice. We'll do a lot of practice actually. And then we'll go into section 5.4.